Okay, we are streaming. I'm going to wait for YouTube to agree. It looks like YouTube agrees. Why is my video blank? There it is. Okay. Hi, everybody. Smitty Halibut here. We are back. Paul and me. Nope, that's not what I wanted to do. We are going to copy some links and paste them. Paul, I'm going to put it into Zoom chat. And then I will link it over on Discord. Excuse me. Another live stream. Okay, it's on Ham Radio Workbench Discord. Let me go to Mastodon. Another live stream with Paul. Are you PBRAUN? No. What's your Mastodon login?
P Brown at Mastodon.radio, I believe.
Why is it not auto-completing you? I'm in as Smitty Halibut. Yeah? Okay. Let me make sure P Brown. Am I not following you?
You should be.
P Brown 42?
Yeah.
What? I know this is fascinating streaming, isn't it? Yeah. We've got one viewer, and that might be one of us. Who knows? I don't know why I can't find it. Okay.
Well, hang on here. Then let me pop over to Mastodon.
PUL. It's not finding it. I can't, for the life of me, figure out why.
Oh, you know what? It's because it's my call.
WD9
GCO at Mastodon.radio.
Okay. Starting another live stream with WD9GCO at Mastodon.radio. Doing more work in KiCAD. And paste that link. It's right there. Publish. Okay. All right. We are actually live. And sorry about that slow start, everybody. And here we are. Concurrent viewers, 2. Nope. The graph only shows 1. Okay. Anyway, hi. If you're in the chat room, please say hello so that we know that you're there, and we can answer your questions or try and dodge the peanuts you throw our way or whatever it is that we do. We are going to be looking at some designs that Paul has done on his own. So previously on something, Smitty working on something. Paul and I worked on a user-side adapter for his radios, and he has taken all of the knowledge that he learned with KiCAD and has gone off and, ooh, look at that hardware, and has gone off and designed the radio-side adapter for his particular radio. So again, these are not meant to be the quote-unquote pro versions that Halibut Electronics is making. Halibut Electronics has designed the products to work with any radio and work with any headset. And it's very configurable, and it has all the bells and whistles and snazzy bits. Paul is making a optimized device for his particular use case.
No snazzy bits.
No Well, it's got the necessary snazzy bits.
Couple snazzy bits, yeah. And I've just so people know, I've got one of the Radio Pros on order. So
yep.
That's for the radio here at the house.
Yeah.
So
his circuit looks a lot simpler because he knows exactly what it needs to do and can put in the bits he needs and leave out the bits he doesn't need. Now, we've chatted in email a couple of times about some of the details on this, but for the most part, he did this on his own. And I'm so proud of you. My little boy is growing up. which got a little awkward, I will admit. Say something, Paul?
Yeah, I'm here.
Okay, good.
Yep.
Just looking at the VU meters in OBS and making sure everything is okay.
I am here.
I'm here. But then he had a few questions, and we want to go through and handle those questions on the stream. But before we do that, Paul, can you please describe the circuit you have on the screen?
This is the Radio Not Pro, as I'm calling it. This is the radio half of the OHIS setup. This one has an RG, because this one is going into my POTA rig, which is a little 6U rack or whatever that's got a Yaesu FT857D in it. And so that uses, essentially uses Ethernet cable to connect the microphone. And so I'm thinking about this, that I also can use this for if I want to hear with my Connect System CS800D at home, which also uses Ethernet. So I've got it set up with this. Instead of the original one, just had the specific pins for the Yaesu hardwired through, and then I realized that if I put a jumper in here, I could patch those a little bit differently and make a second one to use with my CS800. So that's what we're doing. So this is the input from the radio. This is the power supply that will also send power down the cable to the little microphone preamp that's in the radio side box.
User side.
This is, I'm sorry, yeah, user side box. This is the input jack for the speaker audio. This is because I don't want to eliminate the speaker, because on the Yaesu, because I use mine with my control head mounted remotely on a little bitty tripod. The headphone jack is on that thing. So in order to get that headphone audio into the OHIS system and get it into my headphones, I need to run it from there all the way back down to the rack and then back out. Or I can use the speaker jack on the back of the radio, which will do the same thing, except it's pumping out speaker level audio. Yeah. But I don't want to eliminate the speaker, because if I just plug that in, then the speaker that I have mounted in the rack won't work. And I want to have the ability to use that.
Yeah.
So what we've done here is we've paralleled the speakers and the headphones. This is a little trimmer to pad down the level for the headphone feed into the OHIS cable. This is just a little single pole, single throw switch to turn the speaker on and off. And this, this jack right here is the output jack that I will plug the rack speaker into.
So you kind of have your own pass-through, kind of. Here's a snazzy bit, because that's one of the snazzy bits that the Radio Pro does, is that it has the pass-through for the radio's stock devices. Right. So you will have the radio's stock microphone, or I'm sorry, stock speaker able to be plugged directly in, and that has a speaker on and off switch, so you can enable it or disable it.
Correct.
But then you can also take a tap off of that, and it always takes a tap off of that and will feed the OHIS headphones from
right. There. Whether the speaker's on or off, the headphones will always get the audio.
Perfect. So what's the stuff between the J9 config header and J1 OHIS socket?
This is the mic level trimmer that will allow me to the standard. So the OHIS standard says that the user side box takes whatever level your microphone is, puts it through a preamp, and sets it to a defined level, and sends that down the wire. Whether or not your radio can use that level the way it is, or if it needs to be adjusted, depends totally on the radio. So this is another little trimmer that will allow me to back down on the OHIS audio if it's a little too hot for the input to the Yaesu. And this is just a blocking capacitor to wait. Okay, my brain just locked up. Oh, okay. This is because this is where the audio, the supply voltage that feeds uh, the preamp in the box is coming through, and this is blocking that from going into the headphone jack or the microphone jack.
It's
right?
blocking it from going into the radio.
Right.
Correct. Yeah. So that's where the bias voltage comes in.
Yep.
Yeah. So OHIS standard includes a bias voltage on the microphone plus line. And so that is what's providing that bias voltage. The C4 is preventing that bias voltage from getting sent back into the radio, which probably does not want you to backfeed DC voltage into its mic preamp.
Correct.
Yeah.
And then this jack right here is the OHIS jack. So this one is the standard that if this is all set up properly, anybody with a set of headphones into an OHIS user box, whether it's one of the user pros or something that they designed that meets the standard, will work with my radio, regardless of whatever level they are and whatever level I take. It's standard. And that's the whole thing behind OHIS, is that it's a standard connection between any headset and any radio.
I should pay you to promote the OHIS standard.
I'm learning how it all works.
Speaking
and
of
I'm
which,
behind it.
Are we allowed to talk about the where I will be talking about OHIS?
You absolutely are.
So Paul has been nice enough to invite me to the Amateur Radio Newsline Town Hall. Did I describe that right?
You did.
Okay, so the town hall, I believe, is at 10:30.
It's at 11:30 Ohio time on Friday morning in Forum Hall 2
at Hamvention 2023.
Yep.
Yeah.
This is a feature that was a really popular event for years at Hamvention until our founder passed away, because it was his baby.
Yeah.
And it hasn't been done since Bill passed away, but we all kind of decided it was time to bring it back. So we have 3 guests. One of them is Riley Hollingsworth, who is former FCC enforcement director, who is now in charge of the ARRL's volunteer monitor program. He's going to talk about that. We've got Tim Elam, who is the president or the chair of the IARU. So a really big deal. He's going to come in and talk about current topics facing the IARU and how it affects hams around the world. And then also we have this guy coming in to talk about this proposed crazy headset thing that he's
some
doing.
Schmuck.
Yeah. And I thought that would be a really good platform to get this out to a wider audience. And so Mark will be talking about his proposal about what OHIS is and why people should look to adopt it.
Awesome. Thank you very much for giving me that platform. I really appreciate it.
You are welcome.
Which reminds me, I need to get OHIS.org to suck a lot less than it does right now.
Give me some stuff and I'll update it.
Yeah, we got to work on that. All right.
And we also got to work on your PowerPoint presentation.
Yeah.
It's all right.
Yeah.
Okay. It's not like you don't have a business to run in the meantime as well.
That's true. Okay, hang on. I need a to-do list on this. To-do.org. Yep. Slides for ARN Town Hall. And make OHIS.org not suck. That's a good to-do list item, right?
There you go.
Added that to my to-do list. All right, so let's get started on your board here. Now, you told me you had a few questions, and let's go through those questions and try to address them.
Okay, so when I imported, now we're going to change the dimensions of the board, as we discussed before we started streaming.
Yeah.
But so when I imported, I drew the board to the original dimensions, and I imported the circuit, and that mostly worked, except that here, this is the 2-pin header for the little speaker on off switch, which I'm just going to use a panel mount toggle switch rather than try to put something on the board. But when I imported, it was an error. It said that there's nothing connected to these. It said there was no net or something defined for these. And it's like, well, I'm sorry, but over here, I dropped in the 2-pin header and I drew wires to it.
Yep.
So that part I didn't quite get.
Okay.
And then over here, this is all nice and neat.
Yeah.
Over here, not so much.
Not so nice. Zoom
because
in on
this
that,
is a wild tangle of wires that these numbers are not in order. And
zoom into that area so we can see that better.
Yeah.
Because the rat's nests are pretty dark. They don't show up. Yeah. That rat's nest is ugly. Why is that so ugly?
Because it's like these numbers, instead of going up and down a row, it's like they go 1, 2, 3, 4.
Yep.
So that's all. So is this a case where instead of a 2x8, I should have done 2 1x8 side by side?
Nope.
You'll know how to fix this.
Yes, I do.
All right, then.
But you had another thing that you wanted to look at. What was that? 3?
That was the primary mess was, and I think some of this mess over here gets fixed when we fix this mess.
Okay.
But we need, we were going to change, because this was a coax barrel power input, and I think we were just going to standardize on power poles.
Power pole of the world.
Yeah.
But we didn't have enough physical space there to put a power pole. But we will once we get the new board dimensions.
Right, because there was not enough space in this box to put the speaker jack and an RJ45 and power.
But there is
plenty of space there. Yes.
So this box is 100 millimeters wide and 128 millimeters deep. I picked up this and 9 others just like it at a flea market probably 5 to 10 years ago. It was before COVID, I know that. And I don't have a part number for them. They're not reproducible. They would be fine for personal projects, but not for a mass-produced project. And so I haven't done anything with these. But since Paul's not planning on mass-producing this, he's just doing this as a one-off or maybe a 5-off, because that's how many PC boards you get in an order. I'm going to send him some of these cases.
And that's twice as wide as this is, because this is 50 millimeters wide. So
yeah, and this is
plenty of
100. Room. So we got plenty of space. All right, so we're gonna settle on Anderson power pole. So those were the 3 things. Let's look at the first one. So go back to your schematic and look at the pin names on your speaker on-off switch, because the speaker on-off switch is the one that we're looking at, right? The pins are named A1 and B1.
Right.
All right. Bring up your board. Those are labeled 1 and 2.
Which is different.
So we need to have either a schematic outline that is labeled 1 and 2, or a board footprint that is labeled A1 and B1. We need to go one way or the other. Trainman and Kyle. So Kyle AA0Z is in the chat room. Thanks for coming along, Kyle.
Hi, Kyle.
And Trainman419 also came in. I know who that is. Namniart, or I guess Namniart is Trainman backwards. Maybe I should have said that Trainman is Namniart backwards.
Yeah,
anyway, hey, Austin, good to see you. Power pole, all the things. Indeed. Everything I design is designed with power poles. So,
and conveniently, my Poda rig has one of those nifty little ham radio workbench power poles distros mounted in the back.
Oh man, we should make more of those.
You should, because I've got 2, because the other one is in my battery box.
Yeah, I actually want to talk to George about that. We keep missing each other. I need to talk to him and see whether that's something he wants Halibut Electronics to do for the podcast.
Yep.
But we'll figure that out. Okay. So drop another component on there, an outline, and let's take a look. So, Yeah, just do connector. So which is the one that you used? Actually, no, pin header I think is the hit escape. There you go.
I have pin header. I use the same pin header that we used on the user side one, which is why I was confused. The footprint is 2.4 millimeters,
Yeah.
2x1 vertical. And it says connect your 2x1 row letter first.
Ha ha ha. There we go. All right. So go back to your
parts picker.
Parts picker. Yep.
So delete this one.
Yeah. Go ahead for now.
Okay.
Go to we want pin header, not connector. So
mounting pin.
No. Just generic then. Yeah, so see how those are numbered 1 and 2?
Mm-hmm.
Now, the unfortunate thing is that they both come out the same side of the schematic drawing, but I think that's okay. And then, yeah, you're just going to go down to pin header.
2.4.
Hey, Brian.
2.54 vertical, right?
That looks right to me. Yep, that's the correct one. So now the fact that your schematic is labeled 1 and 2 and your board footprint is labeled 1 and 2, that's the important part. So what it was complaining about before is that the pins that the nodes connected to, so your schematic nodes connected to pins A1 and B1, but when you went over to import that into the board layout, it didn't have an A1 and B1 with nodes connected to it. It had a pin 1 and a pin 2 that were disconnected. And so it was trying to tell you that there were no nodes connected to pins 1 and 2 on your connector.
Got it.
So that's the solution to this problem here, was picking a different schematic component. Okay. Now, let's go over and take a look at your config header. The same thing is true over here. We don't actually care whether the real pin numbers line up between the RJ45 and the pin header. We just want them to line up, like, physically, right? The pin numbers are irrelevant. So go back to your board. I also want to take a moment to say hi to Brian, who's just hopped in, jumped. Let me read again. Just dropping in for a few minutes to say hello to you guys. Hello, Brian. N1FIY. I have always read your call sign as Nifty. There's no T in it, but I read it as Nifty, and I figure Nifty is pretty nifty, so I don't think you would be offended by that. You are Nifty in my head. Like, whenever I think about your identity, your person in my head, you're nifty. And I think that's, yeah, everyone does, he says. So, yeah. Anyway, it's great. Thanks for dropping in. I appreciate you being here, and I just appreciate you in general. Okay, so look at how these are numbered. It goes across the board first, row first, then column, not column first, then row.
Yeah.
That is a typical numbering for a pin header. So I would rather keep that numbering for the pin header there and then switch the schematic to match the pin header.
Which is starting down here where it says 16 actually 1.
So what you're going to need to do is pick a different component.
Okay.
So again, go back to your component, drop another component on there. And I didn't want to leave Austin or Kyle out of the appreciation, love. I appreciate you guys too. So,
and I'm gonna see Kyle at Xenia. We're all gonna hang around the flagpole on Friday.
Nice. I look forward to. I'm going to be in Xenia as well, so I look forward to seeing you, Kyle, and meeting you and shaking your hand. Okay. Con_01x02. I usually just search for it. I have no idea where it is. Con, not coon.
Yeah, that's the animals in my yard that keep killing my fish. 01
X08,
X08.
actually. No, 02X08. I don't remember what I told
Oh,
you.
that's right. It's 2. Yep.
2X08. All right. Wait, what? Counterclockwise, scroll down one. Or I think odd even is what you want.
Now that has an A column and a B column.
Correct.
1 through 8.
That is not.
Okay.
Yeah, I think odd even is what we want there. So that's the one that matches your footprint. Are you, Austin? Are you going to be at Hamvention? Train man? He says, "Oh, thanks. Glad to hear you're going to Hamvention this year, Smitty."
Okay, so but if to match the footprint, I need to flip it because it's the footprint starts, at least on the board, started 1 and 2 down at the bottom.
Oh, I mean, you can rotate that.
Let's try.
You can rotate it here,
okay.
or you can rotate it there. Whichever is
that's
easier.
that's what the board footprint looked like.
Sweet. Let's do that then.
Okay.
Did you select the footprint, the board footprint, when you dropped the component? I didn't notice whether you did or not.
I don't remember if I did.
Hit E.
Survey
nope.
says no, I didn't.
Thank you for playing.
You know what? I remembered that part is ugly. So let's start over.
No.
Nope.
You were just there.
Okay.
Hit E, go to footprint, click on the little library, the books, and then it's connector underscore pin header underscore 2.54 is going to be the library. So down near the bottom of that list.
Pin header 2.54.
That's socket. Go up to the pin headers.
Pin header 2.54.
There we go. Now we want to look for the 2X08. So you're in the 1 buys right now. So look for the 2 buys.
208 vertical.
Vertical. Yep, that's the one. Okay. No Hamvention for me, Austin says, but I know you've been dreaming about it for years. I have been to Hamvention precisely once, and it was a good experience. It was 2018, and I've been looking forward to going back to it ever since. Yeah, this time I'm going because it is work. I will have a booth there, 3011. Come on by and say hi. I will be selling my common mode current chokes, and I may have a few OHIS hardwares to sell. We'll see. I got to make sure that my EAP users get them first before I start selling them to other people. So, but I will at the very least have common mode current chokes, test rigs to sell. So come on by.
And buy them, even if you're not sure you need one. They're great for club meetings.
It's true. They are. Okay, so we fixed the speaker on off, we fixed the configuration header, and then we wanted to put an Anderson power pole physical connector on your power in. But I don't know. Let's see whether KiCAD comes with Anderson power pole. KiCAD 7 comes with Anderson power pole or not.
I couldn't find, because I ended up trying to import one that I found, but the footprint took up like most of my board, so I think that's not right. But let's see. So
now we're not dropping another component. We're gonna edit the. Oh, you deleted that one.
Hang on.
There you go.
I put it back.
Yep. Just hit E on it.
Footprint.
Sure, yeah. Austin says, everybody needs a common mode current choke. Heck, I even put them on my robots. That is true. You ever want to test them and measure them on a VNA? I've got a thing that will help you for that. Takes differential mode currents out of the VNA, turns them into common mode currents, presents them on a coax connector of your choice. lets you run it through your common mode device, and then takes it out of back through another RF connector, turns it back into differential mode, and sends it into the VNA. So, if you want to measure your robots, let me know. Okay, so yeah, go there, and let's do a picker and see if we can find the Anderson power pole. I don't know. You said you imported?
Yeah, it was, I remember now. It was something that started with A.
Was
nope.
it a mass?
No.
Okay.
Crap.
Card coax in.
I can check my KiCAD library and tell you exactly. Nope. Wait, it was, let's see. I think it put it in documents. Yep, KiCAD. ASMPR 45. Now the 45 is the 45 on down is all the same.
Correct, yeah. 45s,
connector,
30s,
right?
and 15s. The only difference is the gauge of wire that the crimper,
right. Okay,
that the crimp
so
side is meant for. The blades are the same.
So I need to search up
Hey,
here.
look, it's
or
right
over
at the
here?
top.
Oh yeah, okay.
Is that it? Okay.
Yeah.
Okay. All right, so save that. And let's go back to your board. And
do the update thing.
Do the import. Yeah, the update. Okay, hold on.
Oh, look. No errors this time.
Yeah, that's good. Click the delete footprints with no symbols. And I think we want to relink footprints to schematic symbols based on their reference designators. Okay, now click update. Oh, okay. So yeah, pull that. Yeah, the reference designators. Okay, maybe we didn't want to relink. Whoops. Anyway, that's fine. So that is your power switch. Move that into the upper right corner.
You want to do a Control Z and start over?
No.
There.
No.
And that goes down here.
Wherever you want that switch to be.
Yeah. Rotate that to.
Previously, it was in the upper right corner, but. Oh, but since this is your because yes,
right there. This is the speaker jack. So. Oh, you know what? I had it up here because that's where the speaker switch was going to be.
Okay, put it wherever you want it.
That makes sense. So.
Actually, you know what? I'm going to suggest that you keep it down here because routing wires across the board.
It's much easier with the DuPont wires go over there than
Correct.
traces.
Correct.
Got it.
So I would leave it on this side of the board.
Okay.
Go grab J6. That's your config header. Oh, actually, no, you're right. Let's grab that that Anderson power pole first.
Yeah, this is the thing that confused me.
Okay.
Because when I imported it ate up like my whole board.
Yeah, okay. So that purple line is what's called a courtyard. It's meant to be this is dedicated to my part. Don't let anything else go into this outline. You'll notice that all of the other components have them as well. But the reality is, since you're not even going to use P1 and P2. I think those are meant for if you're going to physically tie it down to the board.
Yeah, I was wondering. Okay, now that I look at that, I'm because the actual power pole part is right here.
Yeah,
the blade goes in here, and then
yeah, you don't want any of those.
So that was just one I found in an online library.
Yeah,
that somebody else had drawn.
Okay, so let's do this. Up in the top bar,
Yep.
there is a chip with a red circle and a pen. Left of there? Nope. Right of there.
That one right there.
there. Yeah. Click that. All right. Go find that Anderson power pole connector. So that got imported into connector. All right. So this is the footprint editor.
Okay.
Go ahead and maximize that. Let's make that, embiggen that, the window. Yeah. Zoom in a bit. Okay. So, first thing I think we want to do is we want to get rid of all of those P pins. So you should be able to, all 5 of them.
Yep.
Just select them and delete them. Okay. Select the purple box and shrink in it. Yes. You can grab the...
Oh, it's 4 individual segments.
Oh, is it really? Oh, that's annoying. You can
So
still
let's hold
shrink in
down-
it, but
Let's hold down Command and see if I can pick them all.
it won't let you scale them.
Nope.
Yeah.
So let's do this one.
You
Move.
just grab it and move it over.
Like right there. Good.
Can you click up grid? There you go. Now go ahead and move it closer to the box, but you were not. Yeah, grab that. What the hell? There you go. And then up to the... Why is your grid so weird?
I don't know.
Because it's 0.1 inches. Good grief. Set your grid to like 0.025 or something.
Oh, that's millimeters.
Oh, well, that's part of the problem.
Here, 0.025 inches is
Actually,
right there.
you know what? This probably is a metric component.
Half a millimeter? 0.1 millimeter?
Do 0.1. That'll be awfully damn precise, but it'll let us do it. As soon as you click M, it's going to move you up to the handle up there. Yeah. Now see how far apart that thing is from the top of it? Get it about that same closeness to the side. And you can zoom into that corner to make it easier if you want. Yeah, I would probably move it one more click to the right. There you go.
That looks good.
All right. Now you can highlight the top bar and shrink in it. And you grab that and just, yeah. Now, yep, you got it. Yeah, that's probably good. Woot woot. Do the same thing on the bottom bar. Okay. Looks good to me. So save it.
Done. And get out of full screen. All right. So now.
Did you save that change? Click the...
Yeah, I did Command S.
Oh, Command S. Okay, that does it.
Yeah.
Then, yeah, hit that X. And then right-click on that component on J4 there. And I think there's an update from library. Update footprint.
Update footprint.
Update selected footprints. Update footprint.
Update footprints with this library ID.
No. Well, I mean, yes.
I mean, in this case, there's only one of them.
Yeah. Update selected footprints. Keep it up at selected. And then of the checkboxes, what is it that we're actually changing? Remove text items which are not in library. Update, reset, text invisible layers. Just click all of those.
And there's no 3D model to go with it. So
yeah, click update. There we go. All right. There is your board, or your Anderson power pole. So no, have it stick out farther. So
Oh yeah, because of the overlap of the parts that plug together.
yeah, so it's unfortunate that that artwork doesn't actually show you the dimensions of where that
Yeah.
where those little half circles are. Oh shoot, it was where the P pins were. We probably should have drawn a line across where those pins were. You know, we can go back and undo some of this stuff if we want, but or I can just get out my calipers and measure where that is. But you want it to stick out at least so that the hemispheres stick out past your
yeah, right now I'm
panel.
further than halfway.
That should be plenty.
Yeah.
If you don't mind them sticking out a little bit.
Nope.
That should be plenty.
Okay, so now we need to resize the board for one thing.
To be exactly 100 millimeters.
100 millimeters by 100, so 128 long.
Yes. The connectors will be on the 100 millimeter edge.
Oh, I need to go back to millimeters.
And set your grid. I would set it to like 1 millimeter. Actually, you could, yeah, do 1 millimeter. So now that'll make it, oh, shoot. Actually, okay, we're going to be moving everything around, so that's fine. How are you measuring that box right now?
I'm looking at the bottom on the toolbar where it says width. There's 120, 126, 7, 8.
Perfect.
And then this needs to be 100.
Yep.
Need to drag it this way. Okay.
There you go. So now you
now
want to
one thing I've noticed
that.
is that there's no I'm just so used to, like with a drawing program, you have a little hand where you can grab it and drag it around. And I haven't been able to, aside from zoom out, move over to another center point and zoom in.
Yeah, hold on. I think it's right click. Yeah, right click and drag will be your hand, or left or middle click. Both of them appear to work.
Oh, middle click works. All right, cool. All right, so now we need to move stuff.
Keep in mind that you want to keep at least a couple of millimeters on the edge clear
for the
slide
in copper rails to slide in.
Yeah. Yep. Because you were getting awfully close before.
Yep. Okay, here's the thing. I did that thing where I dragged from the right, which grabbed everything. I need to drag from the left, which won't grab the box.
There you go.
There we go. Remind me, is there a automated way to pick the center lines, or do you manually have to?
Depends on the component.
I mean, of the board.
Oh, no. That is manual. So what I do is I would go over to the, I would select the user drawings layer, and then I would draw a line, not a trace, a line. There you go. And
yeah, my grid won't snap to the corner.
Oh, Jesus. Okay. That's because you had yeah, okay. No, don't do that. Yeah, select just the board and move, hit M, and then now it will it'll snap to, no, don't snap it back where it came from. Snap it to a grid, and that will be a 1 millimeter grid.
Okay.
So now it should be on a grid. So do you want to be doing this in millimeters, or do you want to do this in dirty rotten English or American inches?
Dirty rotten imperial units works fine.
Okay.
So let's go here. There we go.
Oh, okay. That's a good way of picking the center point. It's almost like you're a draftsman.
All that college money had to be good for something.
That's right.
And that's at a 0 degree angle, which is good. 180 degrees. All right. So there is your
center line.
Center line that way.
Yep.
Okay, we have center lines.
Okay. Yeah. Now, footprints have anchor points. And anchor points are where you can grab that footprint by. I always try to design when I create my own footprint, I always try to design it so that the origin, which is the default anchor, that the origin is where dimensions are critical, right? So like where a given pin is generally not critical. Where, for example, in the case of the Anderson power pole, where the board edge should be, that's the critical dimension, right? So I always try to grab that anchor. I always try to place that anchor so that it's centered and right where the board edge should be, so that you can snap it to the board edge.
Okay.
And that'll put it in the right place. So like you'll notice that the anchor for that is right underneath the J5. If I had designed this, it would be along the center line, but it would be, it's not even on the center line, is it?
Well, it's on the, it is.
Scroll in.
It's on the center line of the box itself. The round part is slightly off center.
Yeah, the round part is the one part that matters.
Well, true. The round part is where, so theoretically it should be centered on the center of the round part. Yeah.
It absolutely should be centered on the center part of the round part. The center of the round part, because that's where you're going to have to place the panel. The holes in the panel.
True.
Right? Where the rest of it is on the board is somewhat irrelevant. It's where that connector interface is the critical dimension.
Yeah, because I got to drill a hole there.
Yeah.
This could be hanging all over here.
Yeah.
This is the part that goes through the hole in the panel.
Yeah.
All right.
Right?
I
And I would also put the anchor right at the front of the larger width, right? So like I would make it in the center of the round part.
Like right here.
Right there, exactly. And that way you can grab it by that anchor and snap it to the board edge, and then draw a dimension between that anchor and the board center line, and you know exactly where to place that circle.
Yep.
Oi.
All right.
Grab J6 and move it over to J2. That looks much prettier.
It does.
That'll be a heck of a lot easier for you to route.
All right. So now this looks like it's centered.
It is. Yeah.
And that's about as close to the edge of the board as we want to get.
You could probably get one more. Your grid is still a full millimeter. You could probably make that a smaller grid and get that a little bit closer. Go up to oh fuck. These are all millimeters.
Hang on.
Like
Here, I went back to inches.
Yeah, but that doesn't change what your grid is. So go up to 0.025 on the grid. No, up more.
0.025 as in inches.
Yeah, there.
Right there.
So that's the typical grid for us dirty inch people.
Okay.
Oh, shoot. Hold on. The origin for the grid by definition is, or by default, is the upper left corner. And so it's, 1, 2, 3, 4, 5, 6, 7, 8 millimeters, or 0.025, 0.050, 0.075, 0.1 inches from the upper left corner of the page.
Okay.
We don't want that. We want that origin to be placed in the center of the board. We want the grid to be anchored on the center of the board. So there's probably a button you can press, but I just remember it as S. So hover over the center of the board, hit S, then enter.
It just lit up a circle, which means now it's in the hit. Okay.
Yep. So now your grid will always be on that
snap
point.
To the center of the board.
Your grid the center of your board will always be a grid point.
Got it.
And then now the grid will be measured however many millimeters or inches from the center of the board.
Perfect.
Instead of from the upper left corner of your page.
Okay.
So actually, you may want to go replace the components over on the left to make sure that they are on your new grid.
Okay, it snapped to that, which appears to be centered.
It is definitely centered up and down. Move it left or right. Okay, actually, that dim vertical line is where it started. So yeah, go ahead and go back one more. As long as you're not directly over that line, then you're good. So yeah, snap right there is fine.
Okay. And that looks like about as close as I'd want to get to the edge.
Sure. Well, go one more to the left and see where the left. The other left.
That's the other right.
Oh, that's a little bit over. Then yeah, bring it back one tick. There you go.
Okay. And then the power poles, we're guessing, but I am way past half. Oh wait, you know what?
Oh, look at that.
There's a gray line here. Is that the notch?
So the gray is, I don't remember what outline.
I bet the gray is that's the notch.
Probably, yeah. So I would bring it back to the right a little bit farther. Of course, you can barely see the gray. Make sure the notch is at least a millimeter past the edge of the board. Technically 1.6 millimeters past the edge of the board. Because remember, you're going to have another board width as your panel.
Right. Okay, so here's the edge of the gray.
Yep.
Okay.
Yeah, that's probably good enough.
And I probably want to drop that down a little bit because we've got box edge, board edge here.
Yeah, it's got to be 2 millimeters away from the edge. You're way more than 2 millimeters away from the edge. So that's.
Oh, okay. All right. So now we do this one.
Oh, notice how it grabbed it by the pin. Right? So you don't want to grab it by the pin. You want to grab it by the center line. So the anchor, hover over the J1.
Oops.
So as soon as you hit M, it'll grab it by whatever anchor is closest. So you want to make sure that you are closest to the origin anchor, not a pin anchor.
Got it.
I think left one more is where the other one is. Yeah, I think that's where the other one is.
And this looks really close to where it should be. All right. And so now we need to this be down here somewhere. This is the speaker or the headphone level trimmer.
Mm-hmm.
we can put right there. And this is the power supply stuff. Okay, so this should probably move. You think this should be closer to the header?
I would probably put it closer to the radio side, yeah.
Okay.
Because it's going to be more powerful, which means you're less likely to pick up noise on the OHIS side.
Okay.
So why did you move it so far to the right? I would keep it over toward the left.
Oh, the radio side.
Yes.
Hi.
Hello.
I'm an idiot.
How you doing?
All right. So let's put it there. Now, why? Okay, I got rat's nests that are...
Yeah, I would rotate it.
Yeah.
There we go. That looks pretty clean. Move it down.
Yeah, it looks better.
Yeah.
Okay. And this is the power supply. It's all kind of in order.
Wait. Zoom into J6. Shoot. Notice how the rat's nest from the RJ45 is connecting to the right side of that header?
Hmm.
And the rat's nest for your pot is connecting to the left side of that header?
That's less than optimal.
It is. Go back to the schematic. We can fix this. Go to the schematic. We can fix this.
Okay.
Select that. Hit M. Then hit X. Bloop. And then plop it back down. So all we did is we swapped it in the X direction. Much cleaner.
Yeah, that looks better. Okay. So I think that's all the schematic mess.
I would move the power supply components closer to the RJ or to the Anderson. Hold on. Don't move anything yet.
Oh, shoot.
That's fine.
I messed up the origin.
That's fine. You can move it. It just means you need to replace the origin. That's all.
I put it back. We're okay.
Okay.
I was just trying to make it a little prettier. This doesn't matter.
Okay.
Okay, so move the power supply stuff up in here.
I would move the power supply stuff closer to the Anderson power pole, yeah. So that you're not running 12 volts all over the place. You're running filtered, regulated 5 volts.
However, I appear to have... Okay, so this has got red down here and black up here.
Which, according to my connector, is correct.
Okay, so then I need to flip some stuff over.
No.
Because
Oh, yeah. You need to rotate the components, yes.
I've got the capacitors.
Okay. My video is mirror imaged because Zoom. But I'm looking at it here, and it is correct that red is on bottom and black is on top. My video is reversed, so it may not look right on the stream, but I'm looking at it right now, and that is correct. So the way your Anderson is wired up right now is correct.
And then I need to flip the... I just need to flip the regulator, right?
Yeah, just rotate it 90 degrees because it's going to be in, ground, out. So in will be on pin 1, 2 is ground, 3 will be out. The hell? Why is there a trace there?
You know, I had tried doing some stuff before when I realized everything was messed up, and I did not delete that piece.
Fair enough. Here's a neat trick. Go down to the lower right-hand corner in the selection filter.
Yeah.
Turn off all items. And then turn on tracks. Now go back into the board, hit Control-A, delete. It looks like it didn't select anything, but if you do Control-A, delete, after selecting only tracks on the selection filter, that will delete all your tracks.
Okay. It didn't, yeah, there must not be any left.
Yeah, because nothing got highlighted. So
All
turn
right.
your all items back on, otherwise you're not going to be able to operate with anything.
Yeah.
Yep.
Okay.
Yeah.
So I guess the first thing we need to do now is put copper down, right? Are we to that point?
Well, first I would lay out your board edges. Oh,
Okay.
Okay. You're using a different color scheme than I am.
Actually, I can get rid of diagonal lines. I don't need those anymore right now. I only need the horizontal and vertical center points.
Sure.
Okay.
Okay. Is that outer box? What layer is that outer box on? Is that edge cuts?
Oh, you know what?
Hit
No,
E.
it's not.
Hit E. Yes, it is.
Oh, it is. Okay, cool.
Okay.
I did that right.
So
Yay,
my problem is that I use a different color scheme because I'm upgraded from an older version of KiCAD and it maintained the older color scheme. And edge cuts are bright yellow, and that dark gray is it is something else. I'm like, what the heck?
No, there's no no way to make it a different color.
That's not worth doing at this point unless you want to go back to the old color scheme. You can select that in preferences, but stick with the new stuff. That's the way KiCAD's going. So that is edge cuts. So then, you probably want to lay down a copper pour over the entire board.
That's so we got to go up here to front copper.
Yeah, it's the tool immediately beneath the yellow circle, which is your vias. Nope, over on the right side.
Oh.
Are you madly hitting Control S all the time?
Yeah, I am.
Command S, I should say, because you're a Mac user.
And I just draw outside the whole box, right?
Sure. Yep. Nope. You got to do points.
Oh, that's right.
Because that still does a selection. Do front and back. Yep. And select your net, earth. Make it the earth net. Because that's our shield. Right? So this is going to be a shield around everything. Take care, Austin. Altium had a way to do pin swaps on the PCB. Not sure if KiCAD can do the same thing or not. Yeah, I like my schematic and my board matching, so I'm not sure I would want to do that. Anyway, take care, Austin. Thanks for joining us. He says he's leaving.
Okay.
Hit B.
Thanks, Austin.
Hit B for it to fill in the thing, and then there you go. There's your ground pour.
Now we got to do the edges.
Stand by. Do we want the... Yeah, I guess we do, don't we? Power ground to be earth. Because we want earth connected to something.
Well, we want that earth because we have audio ground, which is separate.
Yeah. Okay. All right. What was your follow-up question?
Next thing is to leave
the keep outs for the solder mask.
Is that this?
No.
Keep out.
Because we don't want to keep out the copper.
Oh, we want to keep out the mask.
We want to draw a mask. In fact, you probably don't even need to do a fill. Just do a rectangle. So the rectangle drawing tool over on the right-hand side.
Mm-hmm.
That one. And then select front mask. Actually, if you do... I lied. So go ahead and select the front mask layer. And then do the zone. The same one that you use for copper. Not that one. That one. And then click. Click in the corner. And then select both front and back mask. And hold on. Solid fill. Oh, okay, that's fine. Yeah, go ahead and do that, and then I don't know, bring it down 0.1 inch, 0.05 inch, something like that. So you'll have to figure out what the top edge of the board is. It's not critical. The exact dimension isn't critical. So what's the top edge of the board?
Top edge of the board.
Hit space. And notice how the dx, dy, and dist numbers are all 0 on the very bottom row.
Oh, okay.
Right. Yep. So now you can move up. Oh, you weren't on the corner.
I wasn't exactly on the corner.
Okay. Hit space. There we go. Now go ahead and start your box.
So about there.
Yeah, 0.05 is probably good. And yeah. Edit that, hit E. Interesting. Yeah, no, hit E again. Select bottom mask, yeah, okay. Okay. Why didn't it pop that up when you tried to create it the first time? Yeah, okay. Yes. Do it this way. No, don't lock it. Down one more notch. No. Down so you're moving in the positive direction.
Oh, okay.
Yeah.
That's
075. Bring it down.
That's where we were. Oh, okay. Sorry.
Yeah.
So there.
So we're looking at the dy number.
05?
Sure. That looks awfully small. Why?
That looks smaller than up top.
Yeah. Oh, maybe it's not.
No, actually, it looks the same.
Okay. We're splitting hairs here. You could probably bring that up to an 075 if you wanted to. I mean, you've got plenty of space. Just just drag those down one. Yep, yeah, they're even better. Drag that down by one click. Yep, there you go.
Okay.
Hit B to refill all your zones. All right, now those zones are filled. Go up to View, that very top menu, and View 3D Viewer. Bloop, bloop, bloop. So we've got exposed copper on those edges. Nice. That exposed copper is going to touch the case on these rails here and make this, make a good contact with the case and tie the case into the shield.
Okay.
Rock and roll, man.
Now, we got to do traces, but we also have to do isolation for like the audio grounds.
I would just run them as traces and run them as close to their signal counterparts as possible.
Okay, so
select your copper layer.
Oh, yeah.
You're currently drawing on the mask. Yeah, there you go.
See, this is plus. So we need to go here.
Ugh. It kills me.
Why does it not?
You want to make those wider?
Well, I also want to, I guess maybe I'm trying to remember from before. It will only do point to point. It won't do point to point to point to point.
Correct. You have to start it up again every time.
Got it. Okay, yeah. So I guess we probably want to make them a little wider.
Yeah, okay. Go up to File. And I believe it's going to be in Board Setup. And then on the left-hand side, there's going to be Net Classes. Select Net Classes. So you can tag different nets and say this net belongs to this class, this net belongs to that class, and and then you can give each class different dimensions. We're not going to bother now. There's really no reason to do that. We'll just stick with the default class. So go ahead and so close. Net classes. Okay. Not clearance. Go to track width. I would do like a 0.015 or a 0.020. Probably go 0.020.
Yips.
So close. Excuse me. And that's a pretty wide trace, but that'll be good for both power, because you're not doing anything that's going to pull a lot of power.
Right.
Yeah. Yep. And then pin 3 from there goes out to the output capacitor. Yep, there you go. Okay, stop for a second. Do not grab it from R1. Grab it from C3. And then I'll explain why when you get it routed. Okay. Because any current that is drawn by OHIS, that if you dragged that from R1, that current would pass through the trace between R1 and C3.
Oh, yeah.
And if there was any impedance in that trace between R1 and C3, that's an awfully damn short trace, so it doesn't really matter in this case, but in the larger grand scheme of things, whatever impedance in there would cause noise.
So you want to take it from the same voltage source.
Correct.
Okay.
And the voltage source in this case is the capacitor, the bulk capacitor on the output of your regulator.
Got it.
So you want them to pull from as far upstream as possible. This may be a case of where rotating RV2 might be better. You're going to have to go under no matter what. I'm looking at that now because of the location of the pins on the jumper.
So let me go back up here and finish this part.
Okay. Oh, yeah. Okay. You can click it, and that will lock in the part you've already done.
No, I don't want it. I want it to go straight across. So I want to go.
Okay. Let me show you another trick. Hit escape.
Yep.
Shit, it may be too late. Hit Control Y. No, it's not going to do it. All right, put it back in there with wiggle. And I want to show you the trick. Now, don't make it straight. Don't make it straight, because I'm going to show you the trick to in-straighten it. So
okay,
click,
so go there.
Yeah, and then go in.
And then down.
Okay. So now hover over the big, long horizontal trace. That's the one that you want to drag down.
Escape.
And yeah, go ahead and escape.
Okay.
Then hit D and drag it down.
Oh, look.
Yeah.
It's in straightened.
It is in straightened. D will move a trace in 45s and 90s.
Okay.
So since you grabbed that trace and pulled it down, all the connecting traces will move and wiggle along and maintain 45s and 90s and whatnot. Yeah, no, I would go up first. I mean, make it at a 45. So find out where yeah, like that. Okay, but there, click. There you go. Just like that. And nope, go up on the 45 on that one as well. Yeah. There you go. This is where .020 may be a problem. Can you go straight through those pins? Oh, thank goodness. Oh, yeah.
That's kind of close, isn't it?
Well, let's see. Let's see if it lets you do it. Click 4 and drag it over to 7 and see if it does it. You're good? Nope, nope. I would do 5 first. All right. You know what? Undo those top 2 and redo them like the ones below. Yeah. There you go. All right, hit B. I want to take a look at that. Refill your copper pores. There you go. Okay.
All right.
And you just want all 8 of those connected over. No, this is not a pass-through.
Right. This is one of 2 radios coming in and
yeah,
patching them to.
But you only care about 3 of those pins. So 5 of the pins.
I can get rid of some of these.
No. Leave all 8 over on the left.
Oh, but on the right.
On the right side, we only care about 3 of those pins, don't we?
We only care about 8, 10, 12, and 14.
4 of those pins. Yeah. Yeah. That's PTT, so it connects all the way across. And you will also have to. Oh, so yeah, you have not kept power ground separate. Is that going to be a problem?
Oh, that's right. 14 is power ground for push to talk.
But it has to be.
Or push to talk and the bias. Yeah, 14 is earth, so that's push to talk and also the bias.
Yeah, because it's both. Oh!
I don't need to connect it. It's already connected.
No. Hold on.
Yeah?
Hold on.
I'm holding.
Your bias voltage current return is not on the ground pin of OHIS. It's on the mic minus. It's on the mic ground.
Oh. Which is 8. That's this one.
Shoot. Okay, so we are now officially tying our mic ground to
now
power.
Don't forget, in my case, all 3 of my coming off the connector on the headset all use a common ground. But we want, yeah, I mean, we want the OHIS side to stick with the standard.
Yeah.
Cool. I stumped the smart guy.
Shoot. The correct thing to do here would be to put an isolation transformer in here and make the mic ground domain on OHIS tied to the power ground of your power supply.
Okay.
And then to isolate those grounds so that the mic ground into your radio is not tied to your OHIS power ground, you would isolate those with an audio isolation transformer.
Is there a little bitty one, or is there one that I have to wire in?
No, there are board mount ones. Stand by. What? What is going on? So confused. Did I just break Firefox? Uh-oh. This may have broken our stream. Shoot.
No.
Are we still streaming?
Yeah. Yeah, we're still live.
Okay. Hey, viewers, are we still live?
I'm watching us on another screen.
Okay. Because my Firefox window with my YouTube Studio just went away.
Oh.
And we're only on two viewers right now anyway. So, okay. Sunwater Steel says yes. All right, very good. Thank you, Sunwater Steel. So what I'm going to do is I'm going to bring up eBay, my favorite source for inexpensive components, audio transformer. And I will find a inexpensive EI14 isolation transformer audio N207. $8.80 for 10 of them. You can get them by middle of the week. So I'm going to place this in the chat. Oh, chat's already over here. All right. So, Paul, I just sent you a link to an eBay item. Can you please bring it up so our wonderful YouTube viewers can see what it is? Okay. So these are PC board mount audio isolation transformers. The correct thing to do is to drop one of these on the board between the OHIS side and the radio side. You willing to add 88 cents to your BOM cost?
I'll just continue to tell the wife it's your fault.
All of this has been my fault from the very beginning. So yes. All right.
Yes, let's do that.
Then let's go back to your schematic. We want it between the pot and the radio.
So in here?
Yeah, so drag that pot over to the right. Yes, select all of that. Nope, not in... yeah, sure, okay.
Yeah, we're going to need the room.
Yeah, you're going to need the room, yeah. Oh, yep, I thought you got some stuff down there.
Oh, crap, hang on.
Yep.
I also grabbed wiring for down below.
Yep, I saw that. And hit G instead of M.
Oh, it moves the wires.
Yep.
All right.
All right. Now, of course, you want to cut those wires. Bloop. Bloop. Drop a component on there.
Device?
I don't know where it is. I usually just search for transformer.
Audio?
Audio. Yeah, select audio. That is, yeah. Okay.
It has no default footprint.
That's fine. We can add a footprint to it later. So yeah, do that one. it is big. So you're going to need more space than that. But okay. Go ahead and wire it in. I think it was pins 7 and 9. The other advantage to using the audio isolation transformer is that it does not matter which one is ground now. Yes, that's right. Because audio is coming from the right toward the left. Yeah, so we're okay. We are already blocking DC with C4, so there's not going to be. That seems overkill. Blocking DC with some C4.
Want to make really sure
that's right
that it doesn't come through.
So there's not going to be any DC in the audio transformer. Your radio. If we are 100% sure that your radio is not going to present any DC, then what we have there is fine.
The 100% sure on the Yaesu, because the bias is on a totally separate pin, and if I remember correctly, the well, let's see here. Thought I did a screenshot of the pinout for the CS800 stuff. Hell of it stuff. OHIS. Nope. Nope. Okay. Well, no, I don't remember.
The safe thing to do is to throw a capacitor in there.
In here?
Yeah. Grab a copy of C4 and stick one in parallel. It doesn't matter which leg. You know what? I lied. It's probably better for it to be the mic plus side so that any, like the mic ground is hardwired all the way through and mic plus is the one that's isolated. So that there's no extra DC voltage floating around.
So mic plus is up here, right? Pin 9?
That sounds right.
Yeah.
I think that's where it was, yeah. Oh, yes, looking at how it was wired up to the system before, yes, that is where it was. Yeah, perfect. Stick that there. No, where you had it was just right.
Yeah.
Right there. Yeah. Okay.
Okay. Now go back to the board.
While we're at it, throw an earth on pin 0 of the audio transformer. Yeah, okay. I don't know that the transformers you're getting actually have the tabs that stick down for mounting the transformer to the board. So that may be unused, but might as well put it there. All right,
okay.
Now hit E over that transformer, and let's pick an outline. Or a footprint, sorry. And I think Transformers is the name of the library. THD through hole. Yep. Okay. We're just going to have to poke our way through here looking for... just click the top one and hit down arrow a bunch until we find one that looks right. Yep. Nope, not these. These are all power transformers. Okay, hold on. Stop. Go back up to the NF_ETAL. Go up more. Yeah. What's the spacing on those pins? Can you tell?
I don't know. Does the 1200 have anything to do with it?
I don't remember. Let me bring up mine.
Hey, there's a well, unfortunately, it's not clickable. There's a URL in the description.
Okay, hold on. Oh, that's why. Because I made my own component library.
Of course you did.
Of course I did. No wonder what I'm looking at, what I was thinking of, looked exactly like an audio transformer. Shoot. All right, so what's the pin spacing on these? Inches. Stand by. I'm doing things on my screen that you can't see right now. One, two, three, four. What? No, that's not stupid. Stupid thing. Okay. There and there. So it is 0.2 inches, so 0.1, 0.2, and then 0.4 to the other side. Okay. All right. Discard changes. So zoom in on that area, on that, hover over the pin 6 and hit space.
Okay.
It didn't actually do it. Okay, well, okay, just go there. 0.4 and 0.4. Okay. Well, that's unfortunate because that is not the right outline. Okay, go to the next one in the list. Hover over the pin 4 and let's look at the DXDY because it's going to be measuring it based on the origin, which is over pin 1, under pin 1. 0.5 and 0.3. Nope, that's not it. Shoot. Okay. Then keep going down. Skip all the toroidals. I know it's not those. Look in the worths. Nope, it's not those. And that's it.
That's the end.
Shoot. Rawr. Go up to the top of the list of transformers again. And work your way down. Okay. Yep, no. Wait, go back up to the coil craft. One more. That one. Okay, nope. Go back down. Yeah, those really are the closest. Hover over pin 4 and show me the DXDY values. What? Hover over pin 1. 5 and 3. Nope. Okay, scroll down to the next one. Wait, what? Hover over pin 4.
Four and 4.
Okay. No, our space got whacked out. Hover over. Yeah, okay. I see what it is. So hover over 1 and hover over the origin and hit space.
Okay.
Why are the DXDY numbers not changing? You hit space?
I did. Try again.
All right.
Forget
it. The X and Y numbers are what I should be looking at. Okay. I'm just used to having to reset that. Okay, hover over 4. That's 4.4 and 0.4 inches. Damn it. So the dimensions we're looking for are 0.4 and 0.2 inches.
Can we make a copy and edit this?
Yeah, I think that's what we're doing. All right, select that. And then click OK. Oh,
edit symbol?
Edit symbol, yes. No.
No, we don't want to edit the symbol. We want to handle the footprint.
Cancel out of this. Yeah, hit E. And is there a change symbol, update symbol from library? No, we'll have to do it elsewhere. Okay, that's fine. Yeah. Go to the chip with the red circle. That one, yeah. Search for transformer audio. Oh, that's right. Well, try that. Transformer space audio.
They only show those 2 Lundalls.
Yeah, which are not what we want. Okay. So, yeah, just find the transformer underscore THT library. These are all SMT. You need to find the THTs.
Oh. Remember which one we picked?
Yeah, I don't know that it matters. Yeah, grab that. That's the one that we were looking at. So double click it.
1165?
Yeah. Double click it. And then before we make any changes, go up to File and do... Nope, I lied. Go back over to the thing. Hover in the black area. Do not save it. Over there, hit E. This footprint properties. Okay, there we go. We want to change the name. So transformer, what is this called? Make it transformer underscore audio
underscore eBay.
Sure. And then in footprint name, change the names down below as well.
Oh, and here's where at least for right now, we can put this. And then just say okay.
Sorry, I was looking at something else. Get rid of the ETAL P1165s because that's no
what
longer
this
correct.
is at all.
Yeah. Oh, there you go. And honestly, I would get rid of the NF on the transformer as well. And put audio in there. Okay. Yep. Now, we're also going to need to change pin numbers as well. Take the artwork in the right and drag in the center and drag it to the right, because we're going to need to put the pins where that is. You're going to have to select the whole thing. Oh my goodness.
Yeah, I dragged it to the right.
Oh, not the whole thing. I'm sorry. I meant all of the artwork in the middle.
Oh, I see.
Yeah. Control Z. There you go. No, just like the 1-to-1 and the transformer symbols. Yeah, just the middle artwork. And then drag that, like move that over to the right. What's your grid set to? 0.1 millimeter. That's why it's so damn tight. Okay. Wait a minute. Are you still moving, or have you placed that?
Is that far enough?
Get it as close as you can, because it's... Yeah, that's fine. Go select inches again. Over on the left-hand side, set your... No, of just the... no. Not there. Yeah, that window.
Oh, I didn't see that there. Okay.
Yep, select inches and set your grid to 0.025. Nope, 0.025 inches, so up. Right there, yeah. So now select that pad and drag it over to minus 0.2. 4, 1, 2, 3, 4. Same thing there. One more. Are those...
Okay.
God, that looks really...
Is that transformer artwork one piece? Can we move the coils in closer to the core?
Yeah, you could. I think so. And honestly, we don't even need the artwork.
Okay.
It's really not that critical.
Okay, so now we need to make this spacing.
Yeah, and that's what I'm bringing mine up again to look at. Is it really... Yeah, it's 0.2 and 0.4. Okay, hover over pin 4. Minus 0.2 and 0.4. So that's the correct spacing.
Oh, so the way it is.
Yeah, just the way it is right now. Now, the outside bounding box of the transformer...
We need to get rid of this too, right? The 6 and the 4.
Yeah. I mean,
I don't know what...
Those are fab. Just delete all of that shit. I don't think it's going to show up. It's not... All of that light gray stuff, just delete it. It's not going to show up anywhere. You can also go into the selection filter.
Wow, the letters are all made up of individual little segments.
This is BS. I don't know where it all came from. Go to the selection filter, uncheck all items, and then check graphics, I think is what you want. And then do a Control-A, delete. Oh, nope.
Yep, don't want to do that.
Undo that. Okay, instead of doing that, just drag over all of the pads. Yeah. Now you can delete that.
I'm getting rid of the pads?
No, you're not. Because you were only selecting graphics.
Oh.
There you go.
Got it. Okay.
Now reselect all items. Okay. Now we're going to draw a bounding box. You already have a bounding box. We're going to drag... Seriously? It's not even a box?
No.
Oh, my God. These stock footprints, I swear. 0.3 and 0.3 and 2.5 and 2.5. Okay. So draw a bounding box that is, and you're on silk screen already. Yeah. It's going to be 0.5 wide and 0.6 tall, centered around those pins. So you are drawing a box now. So you're not doing, move
Here's
down and you'll see the box expand out.
Oh,
yeah.
Okay, cool.
So 0.5 tall and 0.6 wide. So go ahead and go all the way out to 0.6. And then you can drag it and center it over those pins. Ugh. Get rid of the other artwork. I don't know why we bothered starting with that artwork. No, leave that there. The reference. Yeah. Yep. That's the value. And then the reference is the, reference. Okay. That looks pretty good.
Okay.
And we've already saved it. Yep. Okay. Save it. Now, I will tell you that we're doing something a little bit dirty because we are editing the stock libraries that come with KiCAD.
Yeah.
But you had already done that when you imported the Anderson power pole. I think it deals with that better now than it did back in KiCAD 4 days when they first did this and it got all jacked up. The conventional wisdom at that time was to create your own library to put your own parts in, but then things are not organized. So, all right, that looks good. Save this and then head back over to your board, and let's import all of that. Da-da-da. Okay, so that's going to go between J6 and RV2. So you're going to want to drag RV2 over to the right and then stick that transformer and capacitor between it and the jumper.
G, right?
I don't think it's going to work here.
We're going to have to get rid of the traces and redraw them.
If you you will have to get rid of the traces. Yeah. So grab RV2 and move it to the right. Being careful of that other... Oh, although we can move that trace if we need to, but plop that right there. Now rotate that. And okay, nope, just the once. Okay, one more time. There we go. So yeah, that looks pretty good. I would center it. What are you doing?
Oops, I didn't mean to do that.
Oh, you messed it all up now. No, that's not true.
Fingers on the wrong key.
Put it over the center line.
Oh, and we're going to get rid of that trace.
Nope, you don't even have to do that.
Because the that's the outline of the thing, which can hang over the trace.
Yep. It's all good.
Okay. Now we got to move C5.
Yep. It will need to get rotated. Wait, what is C5 rat's nest on to J6? Where's it connecting on J6?
Pin 7.
Why?
No, pin 9.
Why?
What is C5? Okay, so that should be in line between 9 and the transformer. So that should be...
Something got reversed again.
1, 2, 3, 4, 5. Okay, so
No.
this is
So
9.
the odd numbers on J6 are over to the RJ45. Head back over to your schematic. The even numbers are on RJ45. I don't know how J6 got reversed. Select it, hit X. Now the odd numbers are connected to the RJ45. Save that and re-import into... Yeah. Okay, there we go. That's better.
So that's down on 10. So it's going to have to, well, we're going to have to move this to, we got to open up a little space for that capacitor, right?
Yeah, sure. Drag the transformer to the right. You got plenty of space there. Get it closer to the
I
pot.
guess we do.
Yeah.
And then just rotate this. Bring it in here.
Oh, shoot. Hold on.
I'm holding.
Zoom in on that audio transformer. What are the pin numbers on that? 1, 3, 4, and 6. Go back to your schematic. 1, 2, 3, and 4. Damn it. All right. Open up the component editor, the footprint editor where we just were.
That's this.
The chip
this?
with the pen. Yeah, that. Find your audio transformer. Those are the SMTs. Go to the through hole. Audio eBay. Okay. So 1 and 2 are close together, and then 3 and 4 are close together. So
top is 1 and 2.
Yeah. Oh.
Okay.
And then you've already got 3 and 4. That's fine. Number 2. Yep. Technically speaking, 3 and 4 should be swapped, but it's not going to matter. In this context, it's not going to matter. If you ever need to worry about phase preservation, it will, but in this context, it won't.
That did not update.
Go back to your update screen. Because that's not it. Yeah. Hit close. And then select the component. And hit E. I think that if you edit it, that's where the update footprint from library button is. Because we haven't changed what the library is, we changed the library itself. Right? So now
1, 2, 3, 4.
Yeah.
There we go. Okay, so that looks good.
I still don't see 2 tied to anything. Is there a rat's nest coming off of 2?
There is not.
Why is that?
2 should be connected to pin 8.
It sure should. Try start a trace on pin 8 and see if 2 lights up. It sure doesn't. Okay, so one of those 2 green lines does not actually touch something, which is, yeah. But of course, we can't tell which of them it was. No, you had it correct. Highlight that horizontal line and that horizontal wire and delete it.
This one?
Yeah. And then redraw it. All right, save that and then re-import on the schematic. There we go.
There we go.
Okay. So, remember when I said phase doesn't actually matter?
Yes.
Let's put that to the test. Because right now, pin 2 to 8 has to go underneath that capacitor, which we kind of don't want it to do. So what I'd like to do is I'd like to go to your schematic and swap the wires going into pins 1 and 2, which means on the schematic, they're going to cross each other.
Oh, wait. Hang on. I got to get rid of this. I can't make that go away.
Why not? You select it and then you hit delete.
I'm trying.
Okay, move C5 out of the way. Just grab it and move it out of the way for a second. Now try selecting that wire. Okay.
There we go.
Nope. I would move C5 down to pin 2. Yeah, like that. And then that's kind of a convenient way to cross your wires. So we can do this because the phase of which is pin 1 or pin 2 in the audio transformer doesn't matter at all from an audio's perspective. So, but it makes the wiring on this a heck of a lot easier. Right now, our traces don't actually have to cross. Take C5 and rotate C5 first. And yeah, and then drag it down. I would drag it down some more. Make it, yeah, there we go. Yes. And then up and around to go to pin 1. Yep, you got it. Exactly right. And then pin 1 and the capacitor to pin 2 on the transformer. Yep, just like that. And now, yep. Hit, yeah, that's going to have to either go on, yep, there you go, that works. Or you can do it on the bottom layer. But yeah, that works there. We'll probably want to space out some of this stuff a bit so that it's not quite so tight. But yeah, that's totally doable.
Oh, it's doing that because there's another trace
here.
Yeah,
the PTT line is there. But we can get that PTT line and drag it down. It doesn't need to be so straight like that. So hit D. And that'll bring it down a bit. Yeah, there you go. Now there are a couple of things we'll want to look at there. Yep, bring that up. Yeah. There you go. Hit B and refill all your copper pores. There we go. All right. Scroll over to the right. I want to see what happened to that PTT line when we dragged it down. Oh, yeah, that's fine. That pulled out there. All right, so now we have this big area in the middle where copper pore didn't go. So let's drop some vias there so that it
Except
has
we're not done.
We're not
yet.
done. Okay. Yeah, let's go ahead and finish up first.
Yeah.
Because there will be more of
I'm
those.
seeing ugly lines, so this is going to have to come down. Go there.
You'll want to rotate that switch.
Yep.
B. If you're trying to refill it, hit B. There you go. I hate that. I wish there was a better way to control that. Right in the middle. I would recommend going to the bottom layer.
Okay.
So
then let's do this first. That's not going anywhere. Which one am I going to? This one?
yeah. I would go underneath.
On the bottom layer.
Yeah. No.
Okay. Down here.
Yes, exactly. And then go across to that to the 3.5 millimeter, and then from there you can go up. You'll still have to go on the bottom layer to get around to some of those things, but at least it's a shorter. All right.
Yeah, that's going to have to be, or we do this. No, we'll go underneath.
So I would go underneath.
See what else.
Go to the bottom layer.
I think that's everything except those that got to drop down, and then we'll start punching in vias and throw in some artwork.
Yeah, so let's get those bottom layer traces done. Let me show you how to do that. Okay, so this one is easy because you've got pads on both sides. So before you do that, select the blue layer. Yep, there you go. Yep.
Like that? Or would you go out here?
I would feel more comfortable doing it on the outside.
And that commits the cardinal sin of doing a right angle trace. So let's make that prettier.
That's good. That'll do.
See, I can relate to that because my wife and I had a stained glass studio, and right angle cuts are death for glass.
Yeah.
Because it's a stress point and it will break.
Yeah.
Same as a really tight inside curve. You learn things how glass behaves.
Yeah.
Okay, what else did we need?
We need to do the shield on J7. So the outermost, J7 is the 3.5 down at the bottom.
Got a line here too.
Oh, yeah. Mic ground. We'll get to that in a second. So let's. Oh shoot. Okay.
That didn't.
Okay. What are you looking at?
There's nothing left on J7.
Sure there is. Shield has to go up to the OHIS connector.
Oh. Wait, no, this is the speaker output. This is not OH.
Where's headphone ground coming from? We need headphone ground on pin 5 of OHIS.
Okay. So, so that's coming.
Start a trace on pin 5 of OHIS.
Okay.
And where does that highlight?
Oh, look. Down here.
Yeah.
Duh.
There you go.
Right.
Now, unfortunately, we have cornered in the mic ground on pin 3.
Yes, we have.
So I think what I'm going to recommend is for the headphone left trace, the blue trace on the left-hand side, is that delete those traces that are there.
Like this one?
Yep. All of those traces. Delete them all. Yep. Okay. Then what I'm going to suggest is go back to the red layer. Now, drag a trace from pin 4 straight to the left. And make it straight. Don't make it have a little dogtail at the end. Terminate it right there. So nope.
Yeah.
Double click it. Okay, yep, that's fine. That's fine. Do the same thing with pin 8. And terminate. Yes, exactly right there. Now do pin 3. And have it go. Will it go through those pins? Pins 2 and 4? Yes, it will. Drag that all the way over to where it needs to go.
Oh, okay.
Just trace it. No, from the tip on the left.
Oh, okay.
Yeah. Maybe not quite so close to that one, but yeah. Perfect. Okay. So now we are going to hover over those tips, those wire tips that you have hanging out there. Hit V, enter. Nope, I lied. Hit V again. So V is swapping things. Okay, go grab the via tool. V is what you do when you're in the middle of laying a trace. Yeah, click that and drag that and plop it over that tip. And then drop another one over that tip. There you go. Now go back to the blue layer and let's draw a trace. Nope, trace, not a line. There you go. Yep. Click to there, and then from there down to the pot. Either trace, it doesn't matter. Okay. Now I think you're done. Hit B. Let's see what islands we've created. Okay, so we've got some islands in there. Go back to the via tool and click some vias in those blue areas, those islands. Yep.
Oh, they're blue because we're on the bottom layer.
But there's no red layer is the important part, right? Because we have isolated our copper pour.
Okay.
Yep. And try and get as close to the tips of those, like between pins 4 and 6. See if you can fit one in there. Yeah, like get closer to the connector. Oh, undo that one.
Oh, yeah.
There you go. All right, now hit B. Bloop. Perfect. And then you're going to want to do the same thing with that area down there, and then fill in a bunch of vias elsewhere. And I'll show you some other things to look at for via stitching and filling. Yeah, that's pretty dense. You don't need to go that dense.
Oh.
I mean, it's okay. Don't delete. Never mind. Yeah, that kind of density is fine. And then drop some on that big. Yes. Yep. All right. So those are good. Now also put some vias on the outside of those traces so that the via with that long strip has not just the bottom layer to connect to, but the top layer as well. And actually what you're trying to do there is keep the top layer from flapping around. Right? Yeah. Exactly like you're doing.
And put stuff in here.
Yep. it doesn't need to be that dense. But I would put some underneath J7 in between those pins. Or not like literally, yeah, right in there. Yeah, there you go. Also, notice underneath J1 where you've got like a blue trace going this way and a red trace going this way.
Mm-hmm.
Try and put them as close to those corners as you can to try and tie that blue. Yeah, like right there and right there. Exactly. Yeah, that's plenty dense. Hello, James, KI50EB. So James asks, is this the same project as last time? This is the radio side adapter of the same project. So it's not the same board. Last time he was doing the user side, which is between the OHIS standard in the middle and the headset. This time he's doing the other side, the OHIS standard to the radio. And his is a very optimized, Paul's is a very optimized design because it doesn't... he's not trying to solve every radio's problem. He's only trying to solve the problem for his specific radios.
Correct.
Yeah. So his is kind of a less fussy version. More optimized is really kind of the way I like to describe it.
Okay, and they should go up here.
Yeah. It's good to have you, James. Where are we time-wise? 2 hours. Okay. Sorry for being so backlit, but I've been sitting all day and my legs are starting to get to me, so I'm standing up for a bit. But haven't actually raised my desk into standing position. So the camera is like looking straight up at me and then the lighting. Hence backlit. Yeah, wherever you have those little narrow areas, you want to try and via that if you can. Via all the things. Yep. Looking pretty good.
Starting to look like a Starfield screensaver.
Right? Looking real good.
Now we hit Command S, and we start down here.
At some point, I'd also like you to bring up the 3D viewer, but go ahead and finish dropping those vias. Everyone needs a little bossa nova in their life.
Okay.
3D viewer. 3D.
And then I'll need to drop in graphics too. Okay, so 3D viewer is
it's in the view. It's not a button. View. That's brilliant. So apparently the 3D model for the old Transformer
is significantly larger than
is still part of the component that we created. So maybe we didn't want to copy a component.
it'll be tight to get my fingers in there
Yeah,
to
you
put
think?
the capacitor in. Yeah.
You can go into the component editor again, or the footprint editor, and just remove the 3D model. But yeah, that looks pretty good, man.
Okay, now graphics is on the
F silkscreen.
Yeah.
Didn't you create your own Cygnus outline?
I did.
Footprint? So that would be a footprint, wouldn't it? What am I doing? Put
Yep.
those on.
Do I put it over the vias? Yeah, I put it over the vias.
Yeah, vias are tinted.
So that's under
it's going to be a footprint. The little chip. Yeah. I don't know where you put it. Cygnus, there it is.
Under Cygnus.
Yep.
And this is the one that's the proper size, because the other one was the size of the whole board.
Rad. Totally rad.
Okay.
My California showing, isn't it?
That G star thing doesn't show, right?
It does in that context. So if you don't want it to, hit E, or select it and hit E.
Oh, there we go.
And then there's a visible check mark. Uncheck the visible. Yep. Bloop. And
okay,
it's
now if I wanted to put text,
that
was a T, right?
Yep, correct. Well, I don't know how late it is over there in the Central Time Zone, but over here in Pacific, I'm tired.
So am I. So I think we'll wrap this up, and then we'll just have one more. I'll try to do end plates on my own.
Okay.
And maybe we may not need to do another session. I just may need to send them to you.
Okay.
So I've got the dimension. No, I'll need the dimensions for that plate.
Yep.
I've got the dimensions already for the plate for this.
Okay.
And so, so what I need to do is use the fancy measuring tool and measure the actual height of the RJ45 and the actual height of the jacks, and then measure. I'll work with it, and if I got questions, I'll ask.
Sounds good. The RJ45 is flush mount with the board. So
correct. So that just the actual size of the metal box.
Yeah, you'll need to know where the board is inside the metal box, but and then the dimensions of the RJ45 socket itself. Yes,
that's the metal box I was referring to.
Okay, got it. Yeah, yep, correct. You got it, brother. Go back to the 3D viewer.
Looks like a thing.
Show me with the 3D viewer with your artwork on it. There it is. Whew. Man, that's sexy looking.
I like that.
Me too.
This is actually kind of fun. This, of course, is then going to mean I'm going to have to start designing more crap and spending more money.
I will only take the blame for this project. You're going to have to talk to your wife about other projects on your own.
Yeah, the rest, yeah. But, like I had said before, learning how to do this has kind of reignited that part of my brain when I was a kid and I was building stuff out of Forrest Mims books from Radio Shack.
Yeah.
And back then, if you wanted to make a circuit board, you buy the board with the copper and you rub resist tape on or use a resist pen and then borrow a baking dish from your mom and pour ferric chloride in there and swish it back and forth. This is much neater.
Yeah. Oh, yeah. This is way better, being able to send these files off. You have to wait 2 weeks, but it's a heck of a lot easier and more complete. or more convenient. So, of course, now that we're wrapping up, we're getting questions from the chat room. James KI5OEB says, I might have to speak to you again about again this year at Enid Hamfest 23, or I might have you speak again. Oh, okay. If I will, I'll email you tonight if you want. Yes, absolutely. I'll present anywhere that will let me talk. Getting me to shut up is the hard part. Let me spend your money.
Yeah, you'll have to talk to my wife about that.
Yeah, I'm plenty good at spending my own money.
Yeah.
I'm trying to get better about not spending my money is the problem. That's why I have a podcast, so I can spend other people's monies. Emra Ahmet asks, do you want a protection diode for that 7800 regulator? So the correct thing to do would be to throw a fuse and a diode to conduct if the polarity on that Anderson power pole is reversed. Right, so you stick a reverse polarity diode across the plus 12 and ground, so that if you plug it in correctly, the diode does not conduct, but if you plug it in incorrectly, the diode does conduct, and then you make sure that there's a fuse in line. The idea being that if you reverse the polarity on the Anderson power pole, you blow the fuse, that it short circuits across the 12 volts and ground and blows the fuse. Yeah, that would be a good idea. Dropping a diode on there is pretty easy. I don't know if you want to put a fuse in there as well, or assume that you've got a fuse in the Anderson power pole distribution. So, like, I'll let you decide whether you want to do that.
Well, yeah, because my power for this is all coming off of the Workbench one. Yeah. Power distro, so it's all fused.
Yeah. So please forgive me for butchering the pronunciation of your name. This is not a name I'm used to.
I think it's Emra.
Emra. Thank you. What Emra is suggesting is putting a reverse bias diode across the input of your DC. So a diode pointing up. So that it will not conduct in the normal mode, but will conduct if it's plugged in backwards. I would use like a... Oh, yeah, D_small here. Yep. I don't know the sizes.
Wow, there's a lot of them.
There are. Like a 4001 is what I was going to suggest, but I don't know the size of that. I think it's a DO35 or a DO41. No, it's going to be on the diode THT. Shoot. Emerald, do you happen to know the outline name for like a 4001? And then James is suggesting a workbench theme for which part? I'm sorry, we've already went past. What are you suggesting a workbench theme for there, James? I know it's 1N 4001 or 4007 or yeah, whatever. Any of those. Spending. I thought every episode was that.
Package DO41.
There you go. Spending my money. Not vertical. Go for a horizontal.
Yeah.
And relatively short. Yeah, you don't need the big ones. So that one's good. Oh, yeah, that's fine. Have the
so that goes across.
Rotate it upside down. There you go. Yes, across your input and your output. There you go. Oh, just put, okay. 1N 4001, but, you know, that works.
Oh, yeah. Yeah, actually, no, that makes more sense.
Because you actually know the component there.
I may actually have some of those in the junk box.
Woohoo!
All right, so now I got to go back here and I got to import.
Make us have to actually do more work.
And let's see, so that's going to go. Nope.
No, you had it right. Rotate it one more, and then just put that pin straight over the trace. Pin 1 straight over the trace. Yeah, like right there. Yep. And then hit B so that it can pull back from pin 1.
No, it didn't. You know what? It's not straight over the trace.
It doesn't matter. It doesn't matter. It's okay.
Okay.
Yeah.
But then B
should refill
didn't really do anything, did it?
You hit B?
Yeah, I did. And it did nothing.
Hit escape a couple times?
Oh, because I'm still on front silk screen. No, I hit B and it did nothing.
That shouldn't matter. What the heck?
Want me to delete this trace and throw a new one in?
No, I mean that's not what's causing this right now. Turn off the visibility of the zones over on the left-hand side. Yeah, turn that off. Then turn it back on again. Have you tried turning it off and on again? Now hit B.
Nothing.
Move the diode. Yeah. Yeah, drop it there. It's not locked, is it?
B is doing nothing.
What in the hell? All right, yeah, delete that trace and run a new trace. No idea why.
Why is it doing that now?
Are you sure you don't have like a function key stuck somewhere? All right, yeah, delete that trace.
Trying to delete it. And it's just highlighting it.
Hit escape a bunch of times. Save your work. I think KiCAD is wedged. Save, Control or Command S before you do anything else.
I've done that.
Okay.
So close the board editor, reopen it?
Yeah, let's try that. I think KiCAD is wedged. Now hit B again. You may need to close KiCAD all the way out.
Yep.
There we go. Okay. Well, KiCAD got wedged.
All right. Well, there we go. Now we have a board.
Now we have a board.
And let's see. Where's the button to make Gerbers?
Did you get the JLC PCB plugin installed?
Yep, I did.
And so where is it's going to be up to the right of the little DOS prompt. The buttons at the very top on the far right. The other right.
The other right. Yeah, this one here.
Yes.
Fabrication toolkit.
Again, that's a different plugin than the one I'm used to using, so I don't, but it looks like it dropped.
It's already made them.
Yeah.
Now, Gerbers are standard, right?
Gerbers are a standard, correct.
So if I decide to use OSPark instead of JLPCB, the same file, whoever, PCB correct. Way, whatever, the same files correct. Work.
Yeah.
Perfect.
So OSPark also has an option where you can just upload the KiCad_PCB, and they will do all of the export for you.
Okay.
that's the way I did it for the longest time before I wanted to bother figuring out how to export Gerbers. And if you export the Gerbers by hand, it's kind of a manual process, and you just got a bunch of exports you need to do, and then you need to zip it up and then upload it. So by doing it by hand, it's kind of a pain in the ass, and that's why why Osh Park was really nice, because you could just upload the one file, and they would do all the exporting for you.
Okay.
Now with these plugins take that hassle and turn it into a single button click. So whether you upload the KiCAD file or whether you upload the Gerber zip file, I think it's 6 of one, half dozen of the other.
Awesome.
Yeah.
And my buddy who did the graphics for me is doing one that's just the logo for the end plates.
Nice.
So yeah,
very cool.
Helps to have the graphics guy in the house.
Right.
So all right, cool.
Cheers, mate.
Thank you very much.
Thank you so much.
And like
go ahead.
I'll start working on the end plates myself. Depends on how much time I get before. But the thing is, I don't really need all of I just need to make sure I've got the graphics and everything. I can do that on the MacBook on the cruise.
Yeah, that's true.
Well, I got some downtime. The end plates are not fancy.
No.
So
just
I can work on those.
Get the right holes in the right place.
Yep.
Yeah.
Cool.
And make sure you know to drill or to draw holes in the panel using edge cuts.
Okay.
Right? So even if you're doing circular holes or rectangular holes, just put those shapes
on the edge cut
using edge cuts. And that will tell the PCB manufacturer to route out that space and make that whole space go away.
Got it. Cool.
All right. Groovy. Well, thank you, everyone, for joining us. And we will wrap up this live stream, and we'll see you all later. Hopefully, we'll see some of you over at Hamvention in a couple of weeks. I will be in booth 3011. Paul, where are you going to be?
Well, Newsline doesn't have a booth, but I mean, the Friday forum will be there. I'll be around wearing Newsline shirt, and I'm probably going to hang around, the Workbench booth for a little bit until they really get sick of me and kick me out.
That's a challenge, I hear.
Yeah.
As in, like, challenge accepted.
That's right. Yeah. So no, I'll be around, and I'll be wearing a Newsline shirt and stuff too. So if you want to stop by, say hi. It's okay with me.
Sounds good. All right.
It's always fun to meet the people that listen to us, because, it's like you guys, you just sit here in the house and record stuff and put it out in the world, and you don't know if anybody's listening. So It's always fun to meet the people who actually listen to what we do. So
100%. Yeah. So cool.
All right.
Thanks, everybody, for watching the stream, and we'll catch you next time. This is N6MTS, Smitty Halibut. Be good humans.
WD9GCO Paul.
Be good humans.